In this video, we are going to focus on similarity in triangles, calculating unknown sides. There's many clues in these triangles. First thing is that you start with the measurements given and you figure out what we don't know, which is the value of x. Then we look for the matching angles, and that's going to give us some clues to help us substitute into the rule that we're going to write. So I've already put the markings into these triangles. You can see that these two here are corresponding sides. They create an F shape, as do these two here. And this is a common angle to both. What we have on the other side here is alternate angles, the Z shape for both sides. And then we have vertically opposite here in the middle. Let's look at the rule to figure out the missing sides. It's a very odd looking rule. It's about the small triangle and the big triangle. So we have small over big, or divided by big, equals small over big. And we're going to work down the page like we normally do. We're now going to substitute in these values of the small triangle and the big triangle. So number one, we've written the rule. Number two, we're going to put these numbers in, these values given to us here. We want to keep letters on the left and numbers on the right because we are going to progress into our linear equation. So if we look at the small triangle, we want this value of x over here. And its matching side is the 8. You can see here the F shape. So this is the corresponding angles. And we're going to do the opposite on the other side here now. So the same thing but the opposite side, I should say. So the small measurement for this one is the number 2. And when we do the larger triangle, we have to add up both of these measurements. Now I know it doesn't look like it's correct. We have given you a much larger number here in such a small space, but don't worry about that. It's more about the numbers than the actual drawing of the triangle. So we add 2 and 10 and that becomes 12. Now we need to cross multiply, and we always start with the pronumeral first and then we do the other number second. So x times 12 is 12x equals, and 2 times 8 is 16. And now we're going to progress into the linear equation. So this is a multiplication. The opposite of multiplication is division. And the number next to the pronumeral gets given to both sides because what you do to one side, you must do to the other. We know 12 divided by 12 cancels it out and equals 1, and we drop the pronumeral down. We never put the 1 in front of the pronumeral. And then we have a fraction here, and we see if we can put the bottom number into the top. Now 12 goes into 16 once, but it has a remainder. So what we can do straight away, instead of having a whole number answer, which is not going to be the case for us this time, we can simplify this fraction by finding the highest common factor, and that is 4. The highest common factor is 4. It goes into 16 4 times and into 12 3 times. This is an improper fraction, so we should change this to a mixed fraction, a proper fraction, and that would be 1 and 1/3. So rule, substitution, cross multiply, linear equation, and then answer and simplify if needed. We're going to do the same thing here on the right hand side for the second question. We're going to write the rule. So small over big equals small over big. So the rule is written. Now we're going to do our substitution, and again we want letters on the left. So we look for the small section. So we're looking for the small triangle first, and we've got an X, and its matching angle is on the other side. So this is the vertically opposite section here, is 12. And then we have the other two measurements for alternate angles. So this is a 5 for the small triangle and a 10 for the larger one. So you can see there's vertically opposite angles here and some Z shapes for the other ones, so they are alternate angles. Now we're going to cross multiply, starting with the pronumeral and then the other numbers. So x times 10 is 10x equals 12 times 5 is 60. And we now have an equation. This is a multiplication, so opposite of multiplication is division. And we put the number underneath both next to the pronumeral. So what we do to one side, we must do to the other. And we simplify this, divide 10 to 10, it goes once. We don't write the 1, we simply drop the pronumeral down and we go, how many times does 10 go into 60? It goes 6 times. So you can see here that this answer is 6. It's not a fraction. What we're saying here is the value of this side is 6. It's much easier to explain it when you get a whole number here. So if you look at this ratio, you can see 5 is half of 10 and 6 is half of 12. So if we to write a ratio, the small triangle is 1:2 because this is double the size of the small triangle. We've got 2 more questions here. We have 2 right-angled triangles, one small one inside the larger one. And I've matched up the angles and drawn them for you so you can see that both of these, because they are identical in shape, have a matching set, a pair of right angles which are corresponding to each other. We have these 2 angles here which are also corresponding angles, and then we have this one here which is common to both triangles, and that's exactly the same for the example on the right hand side here. We're going to find the missing value of x. So first thing we're going to do is write the rule. So small over big, so small triangle measurement over big triangle measurement equals exactly the same on the other side, small over big. We're now going to substitute in those values, and remember we want to have the pronumeral on the left. So we look at the small triangle first, we take that pronumeral of x and we place it on top and we find the matching length, which is the 30, and then we have a look at the small triangle length here, which is 3, and then to do the large one we must add up the 6 and the 3, which means it's 9. We're now going to cross multiply starting with the pronumeral. So x times 9 is 9x is equal to 3 times 30, which is 90. And now we have a linear equation situation here. This is a multiplication, so the opposite of multiplication is division. We take the number 9 next to the pronumeral and we give it to both sides as the denominator. 9 divided by 9 cancels out to 1, but we don't write the 1 in front of the x when we drop it down. And we go, how many times does 9 go into 90? It goes 10 times. So our missing measurement is 10. So you can see here this is a ratio of 1:3, because this small triangle is the base size of 1, and then to get the larger triangle you enlarge it 3 times. We're now going to do this next question here. It's going to take a lot more calculations in this one, and you're going to see why shortly. So I'm going to write fairly small. So I'm going to write the rule first, as you would normally do. And then I'm going to substitute as you would normally do. So I'm looking for the small triangle first, the value of x, because we always want to try and put the letters on the left in preparation for our linear equation later on. Now, if we're going to look at this side here as x, and then we want to find the biggest side, I can't add x and 8, so I have to actually show it as an 8 plus x, because I can't find out what that is yet, which doesn't help me for the long side, for the big triangle. Then I look for the smaller and place it over the big for the second side here. Now we're going to cross multiply as we would normally do. So x times 12 is 12x. And 3 times 8 plus x we kind of really can't do until we set it up like this. And then we're going to work that. So we're going to drop down the 12x equals, and we're going to multiply in. So 3 times 8 is 24, and 3 times x is 3x. It's a positive 3x, so I must write plus 3x. And now we have the linear equation. I want letters on the left, numbers on the right. Now this shouldn't be here because it should be numbers on this side, not letters. So I'm going to start with the one that I don't want so I can eliminate it. Opposite of positive 3x is negative 3x, and what I do to one side, I must do to the other. So now that's going to cancel out into nothing. I drop the 24 down and I solve this one here. 12x minus 3x equals 9x. So now I have a 9x equals 24. So it's a bit wonky there. Now I continue as I normally do for linear equations. I have a multiplication situation, so I make it division, and I take the number next to the pronumeral and place it under both sides, because what you do to one side you must do to the other. This cancels out into nothing, and I drop the x down. How many times does 9 go into 24? It doesn't go evenly. So it actually goes 2 times with 6 over 9. Now 6 over 9 must be simplified. So 2, and the highest common factor here is 3. So 3 goes into 6 2 times, and 3 goes into 9 3 times. So the answer is 2 2/3. Alright, we have 2 more questions to go through, and this time I've separated the triangles. So we've got a small triangle and a big triangle. So we're going to start with the rule. Small over big equals small over big, and as a reminder, that's small triangle measurement over big triangle measurement. So now we're going to substitute in these values because we've just written the rule. And I've already gone through and marked these. So we know that this angle matches this one, as does this one here. And of course, we only need 2 angles to prove that this one is also the same. So they're separate triangles, but they're matching based on their markings, so they're similar. Alright, so we want to make sure that the pronumeral goes on the left here. So we look at the small triangle and realise that the pronumeral actually sits in the big triangle. But that's okay. We put the small measurement over top and the pronumeral underneath for the big triangle. We ignore the centimetres in this case and we do them at the end for the answer. The next one we have to do the 3 and the 12. So 3 being this smaller measurement over the 12. And now we have to cross multiply. Now we're going to start with the pronumeral. It doesn't matter if it's on top or bottom. When we cross multiply, we start with the pronumeral. And that's x times 3 is 3x equals 5 times 12 is 60. Alright, so now we've got a linear equation here. So the number next to the x goes underneath both. We know it becomes a division because that was originally a multiplication. 3 divided by 3 equals 1. We drop down the x and we go, how many times does 3 go into 60? It goes 20 times, and the units are centimetres. So we now know that x centimetres is actually 20 centimetres. And we can actually see the ratio here. This small triangle, if we say that's the value of 1, that's the base triangle. How many times do we have to enlarge 5 to get to 20? We have to go 4 times 5 is 20. So this is actually a triangle that's 4 times bigger. So we write a ratio of 1 is to 4. Let's take a look at the last question here. You can see we have 2 triangles attached at the apex. So we've got some vertically opposite angles here and some corresponding angles here, and I've already marked them for us. We've got to find 2 pronumerals, x and y. So we're going to start with x equals, and we're going to write the rule. So as you would normally do, small over big equals small over big. It's got to write this small so I can fit the next one in beside it. And we always want to try and put the pronumerals on the left-hand side. So we'll start with this small pronumeral on top, and its matching length is 20 centimetres because it's sharing this line here. Remember, these are normally, I should probably put this in here, parallel lines. So this is like a transversal line cutting through 2 parallel lines, so that's why they share the same line here. So x and 20. And then the other measurement we need to get here is the 40 and the 10. We're not doing anything with the y and the 12 because that comes in later. So the small measurement here is the 10 over the 40. And now we're going to cross multiply as we would. We start with the pronumeral followed by the next number. So x times 40 is 40x equals 10 times 20 is 200. We have a multiplication equation here, so opposite of multiplication is division, and the number next to the pronumeral goes underneath. We cancel out the 40s because 40 divided by 40 equals 1. We drop the x down, we never put the 1 in front of the x, and then we go, how many times does 40 go into 200? It goes 5 times, and it's centimetres because we're using measurements of unit here. So we now know that this is 5 centimetres in length. We're going to solve y now. So y equals small over big equals small over big. Then our second line is our substitution. And again, we want to try and see if we can put the pronumeral of y on the left-hand side because we want letters on the left, numbers on the right, so which helps us later on for our linear equation. So we look at where y is, and we can see that 12 is smaller and y is bigger, so 12 will go on top and y goes underneath. And then we look for another pair of matching sides, so we can still use the 10 and the 40. We don't have to use this one here, we could, but we're going to use the same ones here. So the small one is 10 and the large one is 40. Alright, now we're going to cross multiply starting with the pronumeral, so we can go from the bottom to the top, and y times 10 is 10y, and we can do the next one here, doesn't matter which way the arrows go as long as you know we're cross multiplying, and 12 times 40 is 480. So we now have the equation. We're going to do the opposite and divide because this is multiplication, and the number 10 goes under both sides because what you do to one side you do to the other. 10 divided by 10 cancels out to 1. Drop the pronumeral of y and then go how many times does 10 go into 480? It goes 48 times, and that is 48 centimetres. So now we know that this missing side is 48 centimetres. And if you look at this ratio here, you can see that we've got a smaller triangle here and a larger one there. So if that is the base size of the triangle, that's being the smaller one, we can think about, well, what do we have to do to 10 to get to 40? We have to enlarge it by 4 times. What do we have to do to 12 to get 48? We've got to enlarge it by 4 times. And the same with 5 and 20. So this is a triangle 4 times as big. The ratio is 1:4.